Good morning, colleagues. Today, I would like to talk about the work we are doing at the Laboratory of Applied Digital Technologies here at the NSU. Our work about review recommendation system. As you all probably know, any scientific paper, before getting published in the journal or getting admitted to the conference, goes through the process of peer review. It is the process when the experts in the field read your paper to assess its quality. The thing is, the number of publications is growing each year, and this growth is only getting faster. Each year, we have more and more papers published, and as such, we need more reviewers. How do you find a reviewer? For example, if you are a sole author, you would usually go to the internet, you would look for the papers in the same field, and then extract authors from there. On a big conferences, for example, today you would have like thousands of articles, thousands of reviewers, and most of the times all the information you have about the authors will be their past publications. And as such, in the conferences, this task of finding a correct reviewer for every paper is very prominent. And with recent and just a second. And with the rise of neural networks, namely transformers and LLMs, we can try and use them for this process of finding a reviewer. But why do we care so much about finding a good reviewer? Because bad choice of a reviewer can lead to reviewer lacking expertise in the field, or they can possess a conflict of interest and many other problems, which can all in turn lead to inadequate review, which destroys all the purpose of the peer review as a quality control. And as such, our goal is to develop a review recommendation system for scientific papers on mathematics in Russian. During development, we encountered two big problems. First being that there's no good markup for this task, because the information on who reviewed which articles is very sensitive. Scientific journals are very hesitant on publishing this information. And secondly, even if we had such a data set, the choice of reviewer is very subjective, meaning there's no objective criteria on which author would be a good reviewer. Because we have no ground truth in this task, we decided to approximate real reviewers with the authors that write publications on the same subject. In the literature, the problem we are facing is commonly referred to as reviewer assignment problem. It is usually encountered in big conferences, and as such, there are two approaches to this problem. First one being natural language processing, where you retrieve some features from the textual representation of your article, and then use this information to somehow find a matching reviewer. And second one is optimization algorithms, where you have a set number of papers, set number of reviewers, and you need to somehow distribute these papers across the reviewers in such a way that everyone gets what they want, everyone gets their field of expertise, and they don't get too much work. Well, speaking about review recommendation systems, well, they do exist. Some simple ones use thematic filtration. Basically, they just filter out the papers based on their text. For example, using universal decimal classification codes or mathematical scientific classification codes. More enhanced systems use all kinds of keyword-based algorithms where they extract keywords from the text and abstracts of the papers, and then use these keywords to find reviewers. And recently there appeared algorithms based on neural networks, where they use algorithms such as word-to-vec to learn representations of the text. But the problem here is that we still have nothing to compare with, really, because most of these systems either don't work on mathematical subjects, or were never meant to be openly used, or are offline permanently already. Here's the overview of our algorithm. The core of our algorithm, of our system, is article database, where we have, where for every article we have a pre-computed embedding. When the request comes, we calculate its embedding and run semantic search, where using cosine distance we take the closest articles to the requested. And after that, we have a list of articles similar to the requested from the database. From these articles, we take its authors, and they will be the reviewer candidates. After that, they go through the step of filtration, where they filter out the people who have too few similar articles and have too few recent publications. And then we present it to the user. Also, we experimented with an optional step of LLM reranking. What we did, basically, we supplied LLM with information on the queried articles, on the authors we extracted from the database, and asked the model, which of these authors can understand this paper the best, whose expertise is the most relevant here. Give us a score from 1 to 10. We used few short learning here, and we used Llama 3.1 70B as the model. We were not able to use the bigger model because it would be computationally hard. And we also tried using a smaller model, but it basically gave the same score for every author, so it just defeats the purpose. So about our dataset, we used a snapshot of mathnet.ru database. Mathnet, it is a service that indexes Russian journals on mathematics, physics, and engineering. As such, we have more than 300,000 publications. Most of them are in Russian, some are in English. For every article, we have information on its name, abstract, UDC codes, universal decimal classification codes, and authors. Here's some statistics if someone's interested. And so for every article, we use its name and abstract to calculate its embedding. We use UDC codes for an optional filtering during semantic search, if user so desires. And also, we use its authors as possible reviewer candidates. Speaking about embedding models, we used BERT-like models. First two of them are general-purpose multilingual models. RuBERT is Russian general-purpose model. And also we used two models trained specifically on scientific data, namely SciBERT and Cyrus. As I said earlier, we have no ground truth. And as such, during our experiments, we decided to simulate the work of a user in our system. We take articles from the test sample from the past 2 years and queried them over the base of trained articles from the 10 years before, and then look at the recommendation feed. We also had to invent our own metrics. We measured on the level of articles that we just retrieved from the database and on the level of authors on the final feed. On the article level, we measured how thematically relevant these articles are to the requested, and we use, once again, UDC codes for that. And on author level, we had two ideas for our metrics. First idea being that an author should write in the same subject as the paper and we use UDC codes for that once again. And second idea is that in the absence of the reviewer, the next person who knows the subject of the paper the best is the author themselves. So meaning if author wasn't an author, he would be a good reviewer actually. It is not a new idea. It was introduced before in the other papers. And we use it as our proxy metric. Let's get to the, of course, these formulas if someone's interested. So the main results are that basically we were not able to correctly guess an actual author of the of requested article, unfortunately. However, across all of the models, we are very likely to, at the first place of our recommendation feed, it is very likely that the first author would be very thematically relevant to the paper. It would actually it would actually work in the same field. Unfortunately, Cybert performs badly on our task, which is unsurprising because it was not trained on Russian text. However, Cyrus, that was trained on Russian scientific texts, its results are comparable with the multilingual model, while it being 25 times smaller. So the good pre-training matters here. We also experimented with prompting our embedder. We tried prompting queries to the embedder, and we tried prompting both query and database. It helped the bigger model Mistral, but didn't help to the multilingual. Since we use multilingual as our prod model, as our production model, we decided to not use prompting. It doesn't help us. We also ran experiments measuring the effectiveness of reranking step. As you can see on the after guessing metrics, they improve because when original author of the paper was indeed present in the list of candidates, LLM reranking moves them to the top of the list, which in turn harms the metrics of UDC. Right now, we are planning to do some A/B testing to measure on human evaluation the effectiveness of the reranking step, whether people like it or not. We still did run some internal testing during development. Here's the example of the user interface. Here, users can input the name and abstract of the paper, and also UDC codes to use as filtering if they so choose. As the output, they get a list of authors, their LLM reranker score, their average cosine distance, some information on their articles, and after that, a link to their MathNet page. People inputted basically any data they wanted. We did not have any control over that. And we also asked people to give us some feedback, namely the score from 1 to 5 on how satisfied they are with the recommendation feed. And the feedback most of the time was quite positive. So in conclusion, we developed a review recommendation system on scientific papers on mathematics in Russian. According to the experts, their score of our recommendations was, the average score of our recommendations was about 3.9 out of 5, which is not bad. And also we are able to retrieve the authors that actually work in the in the same field, yes. We are very likely to extract them. So that's all I had to say for the day. Thank you.
Thank you, Danil. Do we have questions from the audience? Right now, it seems to be no. So I have my choice of question right now. Really exciting work. I would like to ask you. You saying that the experts have scored your recommendations as 3.9, as far as I heard. How many experts there were? I mean,
well, we had about we have about 80, I guess. No, not people. 80
labels.
Как это? Feedbacks.
Feedbacks. Okay.
Yes. Yeah. I don't really know about how many people we actually have. Well, more than 10, of course. all I can surely say.
Okay, so 18 feedbacks for the how many recommendations?
An average recommendation feed has length of from 3 to 20, if I remember correctly.
3 to 20 feedbacks for one recommendation.
Depending on the theme and the requested article, of course.
Okay, seems to be reasonable. Thank you. Do you another question? Maybe. Yeah, please.
Okay, Danil, thank you a lot of. Did you open source the prepared data set?
We did not yet. I think we need to talk with MathNet whether it is possible to make it open source. However, all of this information can be easily collected from the site if someone desires. So.
Okay, but I think it's very valuable.
Well, the main point of our work is that for our recommendations, we used data only about name and the abstracts of the papers, since the full text usually not always are available, but abstracts and names are.
Yeah, I see. Okay, thank you.
Thank you, Danil. I have another question before anyone starts another round of questions. Do you have maybe plans for like application of your recommendation system? Maybe you have friendly journal to offer it.
Well, we developed the system for our client in Math Center. So in the future, we indeed plan to make it publicly available, basically for everyone to use. If Math Center, of course, agrees to do so.
Okay, thank you. Any other questions from the audience? Yeah.
Thank you for the talk. So I think I missed some details. So if I publish a single paper on a topic, can I be considered as a reviewer? Just a single paper on the topic.
Well, as soon as you get into our database, which can actually be easily updated at any time, you would be considered a reviewer by our system.
And if I have another 10 authors in that paper with me?
Excuse me?
And if I have another 10 authors, maybe 20 authors with me in that publication, that single publication, so I'll still be considered as a reviewer?
Well, yes, as long as all of your reviewers have enough publications in this subject, well, yes.
So enough publication, it means a single paper is not enough?
Single is not enough.
Okay, and you showed on one slide, you showed some kind of filtering process where you apply some, maybe can you go over some details on that, how you filter out the candidates?
We use some heuristics for that process. Our default settings are that reviewer should have at least 2 papers similar found in the database to the requested article, and at least 5 papers published during the last 10 years. But of course, these parameters are hyperparameters, and user can change them in the user interface.
Okay, so it's a tunable parameter. Okay, thank you.